Hello everyone, my name is Leela Manikrishna and my roll number is 21bq1a05i0. I am from 3CSCC. Today I would like to present a seminar from the subject data warehousing and data mining. So let us dive into the topic. So I have chosen the topic. So we have data pre-processing steps and one of the step among that one is data cleaning. So I would like to briefly discuss about smoothing of noise in data cleaning. Smoothing of noise. So first let us discuss about what is noise. So in data set, if there is any error, it is treated as noise. So what is noise? Error in the data set. So now there are nearly 4 methods or ways to implement smoothing of noise. First one is binning. Second one is clustering. And third one is human and computer inspection. Human and computer inspection. And coming to the last one, it is binning, clustering, human and computer inspection. And coming to the last one, it is regression. So in regression there are multiple types. Suppose linear and multilinear. So I'll mainly focus on binning topic and I'll explain the remaining 3. So firstly, let us consider about binning. So binning, the term itself represents, so the data must be split into bins. So there are really 4 steps to do binning process. And the first step is, so if there is some data, first we need to sort the data and partition the data into bins having equal size. So sort the data and split into bins of equal size. So the data is sorted and then split into bins of equal size. So this is the first step. And coming to the next step, so as we have mentioned the noise, so the noise data is replaced with mean values. So firstly, the noise data is replaced with mean values of each bin. Mean values of each bin. So as we are splitting the data into equal sized bins, so the noise data is replaced with mean value for a particular bin. And coming to the third step, here noise data is replaced with median value. This is also of each bin. So here firstly we sorted the data and next replacing with mean value, later with median value, and we have the final step, that is replacing the noise data with the nearest neighborhood. So replace noise data with the nearest neighborhood value. So the nearest neighborhood itself represents the value which is nearer to the given data. Now, so have you understood about binning? So there are 4 steps: sorting the data and splitting the data into bins of equal size. Next, replacing with mean values, later with median values, and later nearest neighborhood values. Now let us take an example and I will solve this one. So I will briefly explain about binning and remaining I will just define the terms. Okay, I will explain here. So given data, so let us take the data. So we have the data 15, 8, 4, 21, 24, 21, 34, 25, 28. So now we got the data. So to apply binning procedure, firstly we have to sort the data and split them into bins of equal size. So first let us sort. After sorted, so what is the least value? 4, followed by 8, and then 15. Next here there is repetition, so that's not any problem. 21, 21, 24, and 25, 28, and 34. So the first step is completed. So we have sorted the data. So there is another thing, that is splitting the data into equal bins. So there are how many characters? 1, 2, 3, 4, 5. So there are 9 data. So I am splitting into equal sets. So now I got each bin of size 3. So first step is completed. Next, coming to the next step, noise data is replaced with mean values. So here we are applying the mean values. So what is the mean value of 15, 8 and 4, 27, total by 3. So the mean value will be obviously 9. Okay. Next, applying mean value of this one, 66 by 3. Mean value is 22. And applying here 50, 70, 82, 87. 87 by 3, 29. Okay. So the second step is also completed. So we have completed this task by applying mean value. Next, coming to the median value. So as there are 3 in each bin, so the middle value will be the median value. 8, 8, 8. So here we are replacing the noise, entire noise, using firstly mean and then median values. So here it is 21, 21, 21. Here it comes 28, 28 and 28. So the third step is also completed. So we have replaced all the noise with median value. Coming to the last step, nearest neighborhood. Nearest neighborhood. So considering the data 4, 8 and 5, 4 is the starting. So we have to compare 8 with nearest. Is 8 nearer to 4 or 15? Obviously it is 4. And 15 is as it is. Similarly with this case, 21, 21, 24. And here 25. So here 28 is nearer to 25. So nearest neighbor is 25 and 34 is like that. So in this way, you can apply binning procedure. Now let us define the remaining terms. Coming to the next one is clustering. So in the process of smoothing of data, we have another procedure, that is clustering. So clustering is nothing but grouping data based on their similarities. So based on similarities, there is a principle to be remembered using the clustering. So there are some classes and there are some similarities. So if it is within the class, it is termed as intra, and between the classes it is inter. So as it is grouping based on similarities, so the similarities within the class must be high. So that is maximizing. So this is the first principle to be remembered, maximizing. So as it is within the class, intra class similarities. And considering multiple classes, there must be minimal similarities between the classes. So the second property is minimizing the inter-class similarities. So among multiple classes, there must be very less similarity. Okay, so the clustering is cleared. Next, coming to the third one, human and computer inspection. Human and computer inspection. So these are also treated as outliers sometimes. See, See, outliers are nothing but the properties or attribute sets which are not necessary. So attributes which are not necessary in determining something. Okay, next coming to the last and final one, that is regression. So let us discuss about regression. I'll explain it with a general example. So the final one is regression. So regression in simple can be determined as the property determines other attribute. Suppose x determines y. Let us take an example. There are in animal classes there is a class named mammal and non-mammal. Mammal and non-mammal. So in determining if a specific animal whether it belongs to mammal or non-mammal, there are certain attributes like gives birth, or warm-blooded or cold-blooded, body temperature. So the regression is sole responsible to determine the best fit model. So it takes the attribute which determines the final outcome whether it is mammal or non-mammal, and that is minimal best fit. So if one attribute determines, so if this is an important attribute and it is having the ability to determine whether it is mammal or non-mammal, so this is best fit model and it comes under regression. And for linear regression, it can take two values determining z. So if two values are able to determine the final attribute, it is linear regression. And for multilinear, it is more than two values. So in this way, we can smooth the noise or we can remove the errors from the noise. Hope you understood this lecture. Thank you.